Welcome to The Explainer. Today we are diving deep into the ancient Indian science of chemistry, metallurgy, and medicine, a field known as Rasāyanaśāstra.
So what exactly is Rasāyanaśāstra? Well, at its very core, it's the science of transformation. But we're not just talking about turning lead into gold here. This was a completely holistic field that blended empirical science with really deep philosophical thought. The goal was to transform materials for medicine, for industry, and, believe it or not, even for spiritual growth.
So here's our roadmap for this journey. We're going to start with the unique philosophy that really powered this science. Then we'll peek into the key texts that documented all of it. After that, we'll explore their absolutely incredible results in metallurgy, and then we'll take a detailed tour of the ancient laboratory itself. All right, let's dive right in.
To really get a handle on the science, we first have to get into the mindset that created it. You see, this wasn't just about chemical processes. It was about a whole world view that shaped every single experiment and discovery.
You know, this ancient mantra really gets to the heart of the Indian knowledge system. The focus was all about collaboration and learning together, not about competition. And the spirit created a uniquely fertile ground for discovery and innovation to just flourish.
And this is a really key distinction to make. Unlike the conflicts we saw between science and religion in other parts of the world, Indian tradition saw scientific inquiry and spiritual thought as these intertwined paths, both totally essential for unlocking the secrets of the universe.
So this unique philosophy wasn't just some abstract idea. It was written down in an incredible library of texts. So let's explore some of the ancient manuals that guided these scientific pioneers.
Okay, so there are actually over 100 of these texts, but two of them are the real heavy hitters, the Rasarnava and the Rasāyanaśāstra. They were so detailed, in fact, that they became key sources for the pioneering historian Acharya P.C. Ray, who first brought all this knowledge to the modern world.
Now get this. This verse from the Rasarnava it's remarkable. It is the world's first ever recorded description of a flame test for identifying metals. That's a foundational technique in chemistry that we still teach in schools today. Incredible.
And if you thought that was impressive, the scope of the second major text, the Rasāyanaśāstra, is just staggering. It has nearly 4,000 verses, detailing an unbelievable 960 different formulations for pretty much everything, from creating alloys to making complex medicines. Okay, so they had this vast library of knowledge. The big question is, what did they do with it? Well, they produced feats of metallurgy that were literally centuries ahead of their time, and their work left a permanent mark on the world. And this kind of mastery doesn't just happen overnight. It evolved over millennia. You can actually see the progression, right? From copper and bronze way back in the ancient Indus Valley, to iron being mentioned in the sacred Rig Veda, and then eventually to the unique mastery of pure zinc distillation around 1000 CE.
We're talking about a global reputation here. Indian iron and steel were world-renowned. They created Wootz steel, a high-carbon crucible steel that was the secret ingredient for the legendary Damascus swords, you know, the ones famous for being unbelievably sharp, flexible, and strong. But honestly, their most impressive achievement might have been with zinc. Now, zinc is a really tricky metal. It boils at 907 degrees Celsius, which is super close to its melting point. So the moment you smelt it, poof, it just turns into a vapor and escapes. So how on earth did they solve this problem? Their solution was pure genius. They literally flipped the entire process upside down. They invented downward distillation. By heating the ore from the top, the zinc vapor was forced to travel down into a cooler collection pot buried underground, where it could condense back into pure liquid metal. This ingenious process made India the world's only producer of pure zinc for centuries.
And it wasn't just pure metals. Their skill with alloys was just as impressive. They perfected what's called the lost wax method, a super sophisticated casting technique used to create these breathtakingly intricate bronze statues, like the world-famous Chola bronzes.
So you're probably wondering, what kind of laboratory could produce all of this amazing stuff? Well, let's step inside and take a tour of the equipment, starting with the general apparatus, which they called yantras.
And let me tell you, these were not your average pots and pans. We're talking about precision instruments. As you can see here, each yantra had a specific name and was designed for a very specific chemical process, whether that was gentle heating, controlled distillation, or complex sublimation.
And what's so cool is you can see the direct ancestors of modern lab equipment right here. For instance, the Balika Yantra, or sand bath, did the exact same job as a modern electric heating mantle, distributing heat gently and evenly to keep the glassware from shattering.
And the parallels just keep going. Just look at the Patana Yantra, with its heated pot, its curved delivery tube, and the cooled collection flask. It's a clear direct ancestor of the distillation setups we use in chemistry labs all over the world today.
All right. So, obviously, to handle the extreme temperatures you need for metallurgy, you're going to need some pretty specialized containers. So let's check out their custom-designed crucibles, known as Mūṣās.
Now this is where it gets really interesting. The level of specialization is just off the charts. They didn't just have one type of crucible, they had dozens. And as you can see, each one was made from a very specific recipe of clay, fibers, and minerals, all tailored for a unique chemical or metallurgical job.
I mean, this is literally advanced material science in action. Centuries ago, they understood that adding specific ingredients like hemp fibers for tensile strength or iron filings for heat resistance would completely change a crucible's properties, engineering it perfectly for a specific task. Okay, so to round out our tour of the ancient lab, we have to talk about the power source, the Puṭas. These were ingeniously simple yet highly effective furnaces designed to provide precise, controlled heat. This table is brilliant because it just perfectly illustrates their mastery over temperature control. This wasn't just about making a big fire. By systematically changing the size of the pit and the amount of fuel, from the huge Puṭa down to the tiny Puṭa, they could get a specific, repeatable temperature for any reaction they needed.
So what this system gave them was basically a dial for temperature, much like turning the dial on a modern lab furnace. It was standardized, it was scalable, and it was a precise method for thermal processing.
So, to bring this all home, Rasāyanaśāstra was a profoundly advanced scientific tradition. It pioneered metallurgy, it developed lab equipment that are the clear ancestors of our own, it laid the foundations for pharmacology and Ayurveda, and it did all of this within a philosophy of collaboration and sustainability.
And this leaves us with a really fascinating thought, doesn't it? In our modern world of hyper-specialization, what can we learn from a science that saw no boundaries at all between the material, the medicinal, and the philosophical? What lessons can their holistic approach offer our world today?